Let's look at solving problem 227 in the 4th edition of Hambley as a way of showing how you can solve it several different ways, but in particular this approach or this illustration will maybe let you know that sometimes it is more effective to actually combine resistors and then expand out from that combined circuit to obtain the actual values that you want. I'm drawing now the circuit associated with problem 227, and the problem asks you to find I sub 1 and I sub 2 in this particular circuit. And what I'm going to do, let me go ahead and try to copy this down so if I need it I can quickly get it back. If you were to just do this brute force, maybe you would just immediately start jumping into this and you go, okay, it looks like a two-mesh problem. I'm going to define a mesh here, a mesh current on the left. Let me call it I sub L since I sub 1 and I sub 2 have already been defined. And here's I sub R. And you're immediately saying I need to solve two equations or find two equations so that I can then define or find these two unknown mesh currents, I sub L and I sub R. If I do that, hopefully it's clear that I sub L is actually equal to I sub 1, and I sub 2 now is the current going down from top to bottom in the middle branch. I sub L actually helps that or supports that current. I sub R takes away or hinders that current flow, and consequently I sub 2 is going to be I sub L minus I sub R. So if we wanted to find I sub 1 and I sub 2, we could do it by simply finding I sub L and I sub R. If we did that, then the equations are not that difficult to write down. We have at mesh 1, we have 4 times I sub L minus 16 going into the negative terminal of our voltage source plus 28 I sub L minus I sub R equaling 0. That's mesh 1. Then mesh 2, since we need two equations in the two unknowns, I sub L and I sub R, starting at the lower left-hand corner of mesh 2, then for this particular KVL equation we have 28 times I sub R minus I sub L. Our positive voltage drop is then from bottom to top in terms of, and then we'll experience a current I sub R minus I sub L plus 7 times I sub R plus 14 I sub R is equal to 0. Those are now our two equations in two unknowns, and we would then solve those for I sub R and I sub L. If I put that into a standard form, let me go ahead and say I'm going to go from right to left, so let me write I sub R first. From mesh number 1, or equation 1, we're going to have minus 28 I sub R. Then we'll have plus 4 and 28 times I sub L, and that's equal to 16. Or we then have this is now 32, and there's one of our equations. The second equation is going to come from our second mesh. That's 28 plus 7 plus 14 I sub R minus 28 I sub L is equal to 0. where this particular coefficient is now 21 and 28, or 49, and that's now our set of two equations in the two unknowns, I sub r and I sub l. And we could solve these in your favorite way or using your favorite approach. If, for example, I solve for I sub l in terms of I sub r in the second equation, I then have 28 I sub l is equal to 49 I sub r. And now I can sort of see these are multiples of 7. I sub l is now 49 over 28 I sub r. This is now 7 times 7 and 4 times 7. One of those 7's cancels, and I'm left with 7 over 4 I sub r for I sub l. Or I sub l is 7/4, almost twice the current in the right mesh. Then I can use that relationship in the first equation to find I sub r. I now have minus 28 I sub r plus, and I think that was 32 I sub l, but I'm going to replace I sub l with what I know it to be in terms of I sub r, which is 7/4 I sub r, and that was equal to 16. This 4 goes into that 8 times. I now have minus 28 plus 56 equaling 16, and that's times I sub r, or I have 28 I sub r is equal to 16. I sub r is now equal to 16 over 28, which I have now, this is 4 times 7, and this is, let's say, 4 times 4. One of those 4's cancels, and I now have I sub r is 4/7 amps. I sub l, if we remember, was 7/4 I sub r, and I sub r is 4/7, and I sub l is now 1 amp. This allows us now to solve for the values that we wanted, which were I sub 1 and I sub 2. I sub 1 was simply I sub l, which is 1 amp, and I sub 2, which was the current going down in the middle vertical branch of that circuit, was actually I sub l minus I sub r, and that is now I sub l, which is 1, minus I sub r, which is 4/7, or I sub 2 is now 3/7 amp. And that's one way to solve the circuit. Another way, which might allow you to see the solution more clearly or check your work as you go, is to actually combine some of these resistors, if we can, and analyze the circuit in a slightly different manner, and then back out the information that we need after we've found the initial values from our collapsed circuit. Here is our circuit again. We have I sub 1 going up and I sub 2 coming down in the middle branch. Suppose that I combine those two series resistors. That will give me a resistance of 21, and now that 21 ohm resistor is in parallel with this 28 ohm resistor, and I'm going to now replace that network, let me say from A to B, with an equivalent resistor, and that's 28 in parallel with 21, which is 28 times 21 over the sum of those, which looks ugly to begin with, but it's 4 times 7 and 3 times 7, all over 49, which is 7 times 7. Those 7s all cancel, and I'm left then with 12 ohms for the equivalent resistor. If I were to now replace these two in parallel, that's going to be a 12 ohm resistor. If I look back at the circuit, I've now replaced this combination or collection of resistors with just a single resistor, which is 12 ohms. Let me resketch the circuit. Resketching the circuit, I now have a circuit that looks like the following. Here's my 12 ohm, here's my 16 volts source, and this is now my 4 ohm, and I need to find, in one part of the solution, I need to find I sub 1. But if I look at that, that's just the same as this mesh current in this equivalent network that I've created. And writing KVL, I see that I have 4I1 minus 16 plus 12I sub 1 is equal to 0, or I now have 16I1 is equal to 16, or I1 is equal to 1 amp, which is what we knew that solution needed to produce if we were going to get an equivalent answer to what we had in the earlier problem. And that wasn't too hard, and you could actually see that very quickly here if you see, oh, 16 volts is actually dropped across 16 ohms, and so that then tells you that I1 is going to be 1 amp. We now need to find I sub 2, but remember, I sub 2 is not the current flowing through that 12 ohm resistor. That's what you can't confuse. If you look back at our original circuit, here's the 16 volt source, here's 4, and that was indeed the same I1 that we had, but now we had a 28 ohm and equivalently a 21 ohm resistor in parallel that were making up that right-hand side, or the 12 ohm resistor that we found for its equivalent. Here is I sub 2, meaning we know how much current is coming in here. This is actually I1, but I1 is now going to get divided or split between I sub 2, and let's go ahead and call this I sub 3. And we've already found this. Now that we've found I1, we can simply do a current divider. And we know that I sub 2, consequently, better be less than I sub 1. From the current divider, we know that I sub 2 is going to be some fraction of the total current, I1, coming in to this particular node and gets split between 28 and 21. And in particular, the current through the 21 ohm resistor should be bigger than the current through the 28 ohm resistor. The current divider formula says that I take the sum of those two currents, and then if I want I sub 2, I actually put in the numerator the resistance of the opposite branch that does not include the I sub 2 current. And now I can see that I sub 2 is actually 3 times 7, and 21 and 28 is 49, so that's 7 times 7 times I sub 1, which was 1. This particular combination of 7's cancel, and I'm left with I sub 2 being 3/7 amp. And that should be consistent with what we had derived before. It's just now that we could intuitively determine fairly quickly, once we have examined this circuit from the perspective of collapsing it down by combining resistors and then expanding it back to obtain the actual current that we need, I sub 2, it was fairly easy to find I sub 1 and I sub 2 doing it in that particular manner in that structure.